Hello everyone, in this video I'm going to solve the plate problem which is loaded as shown in the figure with the help of Ansys. So first let me open the Ansys Mechanical APDL 16 and I'll clear and start new. Okay. So first let me go to the preferences. Let me select the structural and I'll click OK. Then I'll go to preprocessor and I'll go to element type, add, edit, delete, and I'll add the solid quad 4 node 182 element. And then I'll go to the options and here I'll select plane stress with thickness. And then I'll click on OK and I'll close this window. Then I'll have to go to the material properties where I have to define the material model, that is Young's modulus and Poisson's ratio has to be mentioned along with the density. So Young's modulus for steel is 2.111, that is 2.1 into 10 raised to 11 Newton per meter square, and Poisson's ratio is nearly 0.3, and the density for steel value, that is nearly 7,800 kg per meter cube. Okay. After this, I'll go to do the geometric modeling. Yeah. After this, and one more thing, I'll have to mention the thickness. So I'll go to real constants and I'll add the thickness of the material, thickness of the plate, that is 10 mm, which is 0.01 meter, and I'll click on OK, and that's it, which is thickness. Yes. So next I will go to modeling and I'll go to creating areas and I'll create arbitrary area through the key points. Okay, I'll create the arbitrary areas through the key points, and in order to do that I'll have to create the key points first. So I'll create the key points as per the geometric conditions as I'm doing now. The first key point I'll create at point 2, and then I'll create at the point 2 x coordinate, and again y coordinate I'll have to see here. Yeah. I'm doing the meter modeling, so I'll have to take in terms of meters the length. So height of the rectangle is 100 mm or 0.1 meter. So that's what I'm going to type here, which is 0.1. I'll create one key point there as well. Okay. Then I'll create one more key point at certain distance from x-axis. Okay. And these are all the key points I'm creating according to the geometry that is needed for it to be loaded, because as you can see, the loads are at particular points in the geometry, and those are the point loads, and hence we need to create the key points at those particular points. So these are the key points that I've created. Now I'll go on creating the areas, that is arbitrary area through the key points. So this is how it goes. Here the only reason why I created key point number 4 and 5 is for the sake of applying point loads. It is very important. Next I will create the circle which is defined in the middle, and that is this solid circle. I'll give its coordinates of the center and the radius of the circle. Yeah. So these are the x and y coordinates of the circle, which is exactly located in the center, and the radius is 15 mm, which is 0.015 meter. So this is the circle at the center. I'll have to create one more circle at the bottom. Even though it's a half circle, actually that is semicircle, but I'll need to create a complete circle, and then I'll have to subtract it from the parent rectangle area. So this is the circle I'm creating for that by mentioning its center coordinates and the radius. Okay, so the second circle is created. Now I'll have to subtract both the circles from the rectangle. So I'll use the Boolean operations to do the subtraction operations on areas. So first I'll have to select the area from which some areas have to be subtracted, that is the rectangle now. And after that I'll select the areas which have to be subtracted. So first let me subtract this, and next let me subtract this circle, the second one. Yeah. Yes. So this is how the Boolean operation is done, and we got the geometry that we required. After this I'll simply mesh this area by bringing the mesh size to the fine, and then I'll simply give the mesh command, so this whole area gets meshed with some warnings, but that is fine. So after this I'll have to go for the loading and boundary condition of this problem. So first I'll apply the constraints, that is on key points where it has to be fixed or basically hinged. So the left bottom key point has to be fixed with respect to x and y direction, and the right bottom key point has to be fixed with respect to y direction, because it can move in x direction because it has the rollers there, if you see. Then I'll apply the force on the key point number 4 here, which is in y direction. Okay, downward y direction makes it the negative value here. So this is the 40 kilonewton load which is applied. The next load will be at the next key point, that is key point number 5, and the load value is minus 50,000 minus, because it's in minus y direction. So this is the loading that has been done, and after this I'll go to solving the problem basically by clicking on current ls, and I'll get the solution, which I have to extract by using general post processor. I'll click on general post processor, and then I'll go to plot results. There I'll go to contour plot, the nodal solution, and then I'll go to stresses, and then von Mises stresses. Okay, and these are the von Mises stresses that we get. Okay, and as you can see, the maximum stress value that we are getting is 0.31 into 10 raised to plus 10. Okay, and this is the displacement plot, or basically the deformation plot is that we are getting. Okay, so this is how to solve the plates problem with the help of mechanical and APDL Ansys. Thank you.